Hi ROS developers, and welcome to this ROS Project special edition OpenAI. So in this series of projects we are working a bit on how to learn how to use OpenAI or any kind of AI system with ROS in ROS Development Studio. So in this project we are going to start a very tiny, very simple project, but I think that because it's so simple that you'll be able to learn step by step all the things that you need to create your own robot and generate your own environment for OpenAI for that robot, and we are going to adapt it to the different changes in the morphology of the robot. So what are we going to do? So we're going to do this Cubli robot, which is a cube that balances itself. So we're not going to start from here, but basically we are going to try to emulate this robot made by Etihad Zurich. Okay? So what do you need to follow this video? Well, I highly recommend you that you follow some courses that we have in Robotics Ignite Academy for this, and one of them is the URDF generation in this video, and in the next one you'll need to, it's highly recommended to do the OpenAI Gen video. So let's get started then. So all the code that we're going to generate in these videos, I'm going to post it in this Git. I'll leave it in the comments down in the description, and you can clone the files that we're going to generate here and follow the video then, okay? So how do we start? Like always, the first thing that we have to do is sign in ROS Development Studio, and you'll be greeted with something like this. In this case, I've created my project already, but you can create it your own project here. Just clicking create new project, you put the name, you select an image, and then you select if you want it private or public. Yeah. In this case, it's more or less this. So as you can see, we are going to try to do this cube only the first circle here. Okay, so in the video that I've shown you, they are 3 circles. We are going to add them in the following videos, but for simplicity we are going to add just 1 circle. So let's get started. So for that we open the project. I already have it opened. Say that I don't want to, and then we're going to open our shell. This is the first thing we have to do. So let's go. In this case, because it's a simulation, we need to put it. It's highly recommended that we put it in the simulation workspace in the source folder. Okay, there we are. So we have already a package done. So we're going to do our own package, and we're going to go step by step to build this cube. Okay? Yeah. So let's do can create package. Let's say my moving cube. Description. Okay, I'll name it exactly as I did in my tests, and that way we can follow along easily. And ROS by only as dependencies for the moment. There we go. So we have it here. We open the IDE, and inside here in let's see. So in the user, simulation, and in the source we have two folders, the one that I did and the one that we just created. Okay, so you can see that you have it empty. So the first thing is, well, the first thing to create a robot is, of course, the URDF. So let's do a folder which is called, see, new folder, there you go, URDF. And inside it, we are going to create a file that it's called my moving cube URDF. Okay, there we go. So we don't have anything. So what I'm going to do is just copy the URDF and by pieces, and we're going to do it that way. I won't make mistakes, and also we go a bit faster. So here I'm going to get the URDF and we're going to select the type. So the first thing you have to do is, like always, put the tag of robots. So robot tag, we need to put XML, and then robots. There we go. And the name. So in my case it's my moving cube. Yep. Okay, then first thing. Well, the first thing is, what do we want to build? So we want to build a cube, and inside it we want 3 cylinders. In this case, in this video, we're going to build just one, and in further videos we will add them because we will see that we need them for some other stuff. So the first thing is, okay, let's put the link, the base link. There we go. So this is just a basic link which is named cube body. That's okay. Then the mass, you can put any mass you want. I've just put this like 500 grams, so 0.5 kilograms, but you can put anything, just adapt your dynamics to that. So if you put more weight, you'll have to make the wheels spin faster. So we build inertia, then collision, and then visuals. Okay, the collision and the visuals are a box with these dimensions, so 0.2 meters width, side and height, and the same here. Okay, inertia. This is important. How do we calculate the inertia? You can do it by hand or with a handy dandy tool that we have installed in ROS Development Studio, which is Spawn Tools Inertia Calculator. And inside here you just select the type of geometry, basic geometry, which is in this case box. The mass is 0.5, 0.2, 0.2, 0.2, and there you have it. And just copy paste. Let me check that we did it correctly. Okay, now we have this. Okay, can we spawn this? Oh, let's try it. So how do we spawn this? How do we spawn this cube? Well, first of all, let's add something which we need, which is the physics element. So we need the Gazebo element here, which is, you have to put the same name here as the link, and then the properties, which are basically how it deforms, it reacts to forces, if it changes the shape or not, or how much, and then the friction. So in this case, we want a lot of friction in the cube because it's the part that it's touching all the time, the floor. And then the color. Let's change the color. Let's put it, I don't know, blue. Okay, fair enough. Now, we want to spawn this robot. This is the first thing we want to do. So let's create a launch file. Let's create a launch file. So we put it in the launch folder, and here let's put, for example, spawn moving cube. Okay, fair enough. So let me copy what I did here so I don't get anything wrong. It's very simple because we have some tools already done in ROS Development Studio, but spawning an element it's not very difficult. Just we have loads of videos explaining that. So let's go to our spawn moving cube, paste it. Let's put this here. Okay. This here. And then we have to put the name of the package where the URDF is. So in our case is this one. There you go. Moving cube, URDF, my moving cube. Okay. And now what? That's it. Well, we have to change this, which I forgot. So my moving cube. There you go. And now what? We spawn it. So let's go here. ROS launch. My moving cube. Spawn cube. Okay, let's see if it's spawned. Well, we don't know if it's spawned because we don't know which simulation we have. So we need some kind of simulation. So let's launch it. So we launch an empty world. Okay. So what? There we go. There we go. So we have our tiny little cube here. Blue one. Perfect. Fantastic. That's it. Okay. We can close, minimize that. So we have it. It works. At least we have a cube. So that's a good thing. Okay. Next step. Well, next step is once we have the spawning, we work on our model. So next step is adding, well, one of the cylinders. I think it's quite direct. So let's add this link here. Maybe I should let me do it a bit bigger. I think it's better. Okay, now we go here and we add our link, which is inertia will roll, because it will rotate in the roll axis, let's say, in the x-axis. Okay, geometry. Well, the inertia is calculated based on the geometry, and the geometry is a cylinder of radius 0.08 and this length. Again, how do we calculate this? We go here and we do our ROS run spawn robot tools, inertia, and then we select cylinder in this case. So 0.5, radius 0.08 and 0.01, and you'll get what I have here. Yeah. Okay. Perfect. So now we have to link them together. So what we're going to do is, what we are going to do, time, is add a link, a joint. Sorry, so let me look for the joint. It's here. I must be blind there. Okay. What more? Oh yeah, I forgot. We need the Gazebo, always the Gazebo tag. Otherwise Gazebo won't know how to calculate the physics. So let me select this. In this case, I'm going to leave it red just because it shows that we're turning around the x-axis, which normally is red. Okay. We leave the names as it is. The inertia, the materials, the friction, it's not important. Okay, and now we have this. Okay, fair enough. Let's try it. Spawn cube. Oh, there we are. So we have our red cylinder here. And we will have to put at the end of all these videos, we'll try to have one in each axis. So in X, in Y, and in Z. Yeah, to give us roll, pitch, and yaw. Okay, so let's delete it. Fantastic. So if you got until here, I think it's quite easy. So now let's add some movement, because now we can't move the cylinders anyway. So to add that, we need to give it transmission, which I put here, and the transmission has to have the same name here as the joint that you want to actuate. And yeah, this is important also. The joint, the values, the effort. We need a lot of force because you'll have to make it spin very fast and change direction really fast also. So we need a lot of effort, so the limit has to be high, and the velocity, it has to be really high. So 1000 radians per second is insane. It's really fast. But the thing is that to make this work, you'll have to move it, give velocities of around 80 radians per second, things like that. 100 radians per second. It's a lot. So it's not very strange that the velocity is that high. And then the axis is turning around the Z. It's because it's the Z-axis of this link. Yeah. And in cylinders, the Z-axis is the height. Yeah. What it's called here, length. Yeah. So the length axis is the Z-axis. And we are turning. This means that we are turning like a wheel. Okay. Yeah. Okay, so we have the transmission, and now we are going to add also this. We need to add this because otherwise we don't have Gazebo control plugin activated. So we'll add it at the top. Yep. And then robot namespace, my moving cube. Okay. And that's it? Well, no. So this is what we need to put in the URDF. I think I didn't. This is a plugin that we'll add at the end. It's for the odometry, so don't worry about that. We have the cube, and the joints and the transmission. Okay. So next thing that we have to add is, you see here that we have a config folder. Let's copy that, a whole folder, and then copy paste, and whoops, sorry, I'll have to add it. There you go. Whoop. Don't know what happened there. Okay. Yeah, so first things first, we have to change the name of the namespace. So if you have a look here, we stated my moving cube, so my moving cube, and then we have the following: joint state controller, type joint state controller, and we publish at around 30 Hertz. It's enough. Okay, it's more than enough in this case for the moment. And then we add our only controller, which is inertial wheel roll joint. Yeah, that's the name of the joint. Velocity, because we're going to control it through velocity. Yeah, we can control by position, velocity, and effort. In this case, velocity. So we have to put effort controllers / joint velocity controller. Yeah. And then what are we controlling? This joint and the PID. In this case, we just put this, which is don't touch anything of the commands that we're sending. Okay. If we see that there's something strange, it goes very slow, or it changes very slow, or maybe it stutters, then we'll have to see what we do with the PIDs. Yep. Okay, so now we need a launch file to launch all this, because for the moment we just have the spawn, and the spawn doesn't do anything. So we go here and we're going to create this, where is it? There we go. We are going to start the controllers. So moving cube control. And we have to do 3 things. 1, load all the things that we stated here. Sorry. Yeah, this one in moving cube. This is 1. Then, so we have to tell him, okay, get it from my moving cube description. My moving cube description. And the moving cube, we leave it like that. Then we have the robot state publisher that will publish all the states, the joint states, the TFs, and so on. So there you go. This is important also. 30 Hertz is more than enough in this case. And then we have the controller spawner, which is the one that spawns all the controllers and make them work. So in this case, we have to put the same name as the guy here. Yeah. Okay, and namespace, it's my moving cube. Be very careful with this because it's a source of errors. Yeah, so it's the same here, and same in our URDF. Okay, it's really important. Okay, and I think that's quite it. Yep. So now, let's spawn our nice cube. First thing, so let's spawn it. There we go. And now we're going to moving cube control. Okay. This is good. you see that it says started joint controllers, the state controller, and the inertial wheel roll joint velocity controller. Okay, how do we know it's working? Well, we have to write something there. So let's launch another terminal and we'll have a look. So ROS topic list and ROS topic pub my cube blah 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 command, and if we double tab it auto completes everything. Okay, so let's put something like, I don't know, like 80. It moved. Perfect. So you can't see it very well, but you see that it's turning like crazy. It's turning like crazy. And the proof that it's turning is that if, for example, we now tell him to go in the other direction at the same speed, due to the conservation of momentum, it moves to the other side. Okay, this is because all the energy that you had spinning, it has to go in the other direction. So that's how you get movement with this cube. But of course, you can only turn in the roll. So you'll need more than one disk to move in three-dimensional space. Yeah, but that's another day. Okay, so I think we'll leave it here for today because yeah, it's like 30 minutes. So next video, what are we going to do? In the next video, we're going to apply this simulation. We're going to use this exact same simulation with OpenAI to make it learn how to move around the space, or at least make him move in one direction, which is the only thing that he can do. Okay, and we'll do it by rewarding the fact that he's moving moving in space. Okay, how we will do that? Well, adding, I'll give you this as bonus. So if you go here to our, we are going to use this plugin, which is basically it gives us perfect odometry and tells us where this link is in the world. And with that, we're going to get the information we need to make the OpenAI learning. And that's it. So in the description of the video, you'll find everything you need to follow this course. So the Git and all the stuff, every links to the courses that I highly recommend you that you do to understand all that we have done and the future things that we'll have to do. And just, if you didn't like the video, thumbs down, but if you liked it, thumbs up. It helps a lot. And subscribe, because we publish videos every day. And that's it. So thank you and see you soon. Hasta la próxima.